So now we will tell about the chemoreceptor. Okay, so chemoreceptor, that actually the blood pressure is regulated by through chemicals. How, what is the chemical? For example, carbon dioxide and oxygen and hydrogen. These are actually compounds. Okay, so this is, that's why if the receptor, if some receptor that regulate, that sense the carbon dioxide, oxygen partial pressure and hydrogen concentration, that are called chemoreceptor. Okay, so now first of all, so there are two receptors present in the body. One is the peripheral peripheral chemoreceptor, peripheral chemoreceptor. Another is the central chemoreceptor. Okay, so peripheral chemoreceptor are actually present in the aortic wall and the carotid. In aortic there is called aortic bodies, aortic aortic bodies. In the carotid, that is called carotid bodies. So you have to remember that there are two receptors. One is the peripheral chemoreceptor, another is carotid central chemoreceptor. Peripheral chemoreceptor are present in the aorta, called aortic body, and carotid, that is called carotid body. So the next thing is that how it can sense. So we will tell about, for example, this is aorta. Here are the aortic bodies present, and when the carbon dioxide partial pressure or oxygen, when the carbon dioxide partial pressure, oxygen partial pressure, and hydrogen ion concentration is changes, they will give signal. For example, if the carbon dioxide is increases, oxygen is decreases, hydrogen ion is increases, so it goes to the carotid, the aortic body sense these changes. Okay, and from this, through the vagus nerve signal goes toward the brainstem, and here is the internal carotid artery. Here are also aortic body, and in the aortic body this is also sent, and after that it goes toward the brainstem. In the brainstem there goes toward the cardiovascular cardio card from the brainstem there goes toward the cardiovascular center. Okay, and from here now there are actually, one is the heart function, the heart function effect actually to compensate these changes. One thing is to the heart function changes, another is also the respiratory rate and depth. Respiratory rate and depth is also changes to compensate these changes. So you have to remember these two activity. Okay, in the first way, for example, when the carbon dioxide is increases, actually first of all the signal goes to our brainstem and cardiovascular center, and actually it cardiovascular center decrease the heart rate. Okay, decrease the heart rate and increase the parasympathetic activity to decrease blood flow, to decrease blood flow. Why? To decrease blood flow, to decrease the blood flow. And actually in the cardiovascular center also have vasomotor center. It actually constrict the veins, constrict the vein. When the vein is constricted, so more blood come to the heart, venous return is increased, mean more blood comes to the heart, and here the heart rate is decreasing, and heart rate is decreases, and contractility is also decreases. So one thing is the venous return is decreased by the vasoconstriction. Okay, venous return is decreased. When venous return is decreased, it means to the lung, it is the lung, so to the lungs more blood goes to the lungs. Okay, so it is simple. And when heart rate is decreased, contractility is decreased, it means that the less blood is moved to the body. Actually when the heart rate is decreased, so it means that the flow of blood flow become decreased. When the blood flow become decreased, so less blood goes toward the tissue, etc., and less nutrient, etc., goes toward the peripheral, so less carbon dioxide is produced. Okay, now let's explain it from our notes. Okay, so first of all, the chemoreceptor, one is the peripheral chemoreceptor, another is the central chemoreceptor. Actually it is present outside the body, and cluster of nerve, one is the aortic body, another is the carotid body. Okay, now aortic carotid body actually monitor the partial pressure of oxygen, partial pressure of carbon dioxide, and pH, concentration of hydrogen ion. Okay, now another is I also, one is the cardiovascular center, I have already explained it. Another is the respiratory center. It is actually present in the pons and medulla oblongata, and autonomic function, autonomic control. Actually, it communicate with the cardiovascular center. I have already tell that this is the cardiovascular center, and actually it communicate with the respiratory center. Okay, so it communicate with the cardiovascular center. So how? Now this is actually lower. Now first of all, this is the nucleus structure solitarius. Okay, nucleus structures. This is the cardiovascular center. Cardiovascular center have nucleus structure solitarius, and this is another thing is the cardiovascular center. What it do? Lower one third of the brainstem it is present. Okay, now it have cardiac accelerator, vasomotor, and cardiac deaccelerator. Cardiac deaccelerator as function is the parasympathetic increase or decrease it. Another is vasomotor center, control diameter of blood flow. I have already discussed. And cardiac accelerator actually sympathetic outflow and heart rate and contractility. It actually increase the heart rate and contractility. Okay, or decrease it. Now later you have to remember this term hypoxemia, hypocapnia, or acidemia. These three are the things. Now if the partial pressure of oxygen is decreases, if the partial pressure of oxygen is decreases, another is the blood. For example, one thing is you have to remember that partial pressure of oxygen is decreases in the arteries. That is called hypoxemia. If the arterial carbon dioxide partial pressure is increases, that is called hypercapnia. Hypercapnia, actually hypercapnia. And another thing is the acidemia, when the blood pH is decreases. Now you have to remember that these all have effect goes toward the through the aortic body through the aortic or carotid body by vagus and glossopharyngeal nerve to a cardiovascular center. I have already discussed that from the vagus it goes toward the cardiovascular center. Okay, when they goes toward the cardiovascular center, what will happen? When the cardiovascular center have different function. First of all, if the oxygen concentration is decreased, carbon dioxide is decreased. Now what will function it? Vasomotor first of all actually decrease the metabolic rate, and another is the vasoconstriction. It actually constrict the vein. When vein constrict, the venous return is increases. When venous return is decreases, so more carbon dioxide goes toward the lungs. Okay, so more carbon dioxide loss of carbon dioxide is increases. First thing is this. Now another thing is the one is the cardiac accelerator, another is the cardiac deaccelerator. Cardiovascular center have effect on the heart, that is cardiac accelerator and cardiac deaccelerator. There both of them will function. So what the function will it do? It actually, now you have to remember, it actually decrease the heart rate and contractility by decreases sympathetic effect. Okay, another thing is increase the parasympathetic effect, so the heart rate is decreases. So you have to remember that one is the vasoconstriction. When constrict, so more blood goes toward the lungs. Okay, another is the it actually decrease the heart rate. When it actually decrease the heart rate, so when less so heart rate is decreased, so less blood moves toward the body and periphery, and less carbon dioxide is produced. Okay, now up to this we have explained everything. Now after this, respiratory center is activated. So respiratory center gives information to the lung through vagus and glossopharyngeal nerve. Okay, so what it do? It actually first fast and deep diaphragm. This is the diaphragm. Okay, so the deep inspiration, the diaphragm is more deep, go more deep, and more air come inside. So more oxygen come to the blood. More oxygen come to the blood, and more carbon dioxide is excreted. So you have to remember one effect is also done here, that more carbon dioxide intake happen and more carbon dioxide output is happen. Okay, so what will happen after did the airway is become stretched? This is the airway and it stretches. Okay, so what when it stretch, it have a pulmonary stretch receptor. So that pulmonary stretch receptor is activated, and they give information by the vagus nerve stretch receptor to the medulla oblongata to slow down. For example, now there is another mechanism actually that is different. For example, respiratory center is activated. Okay, so more air come inside. When more air is come inside, so what will happen when more come air inside? So this is the lung, and they become more more stretch. Okay, so when more stretch, so there is the stretch receptor is activated. When stretch receptor is activated, they give information they give information toward medulla, okay, to slow down because it is not important that, for example, if this mechanism increases the the breathing rate, one is the, for example, respiratory center activated and breathing is increases and depth is increasing, so it is maybe dangerous, okay, sometimes. So that's why if the stretch receptor is activated to slow down, because first thing is that the breathing need to become so high and depth is also become so high for the first time. But if the level of carbon dioxide is, it's not too much time, okay, it's less time, so give information to medulla to slow down, okay. So what will happen after that? Cardiac accelerator, medulla also give information to cardiac accelerator and cardiac deaccelerator. What it will do, it actually now for example, oxygen concentration, carbon dioxide concentration is become normal, okay, become because more oxygen come in and more carbon dioxide is too. If this mechanism, so after this, when this is become normal, so the one thing is the medulla oblongata slow the breathing, another is the cardiac accelerator increase the heart rate and contractility. When this is increased, so more blood goes toward the peripheral, etc. Okay, so actually reverse effect. This is actually the reverse. So if you see this mechanism, this is actually the reverse effect. This all is the actually when the stretch receptor is activated, so this all is actually the reverse effect of the peripheral chemoreceptor, okay. So the peripheral chemoreceptor, more blood, so more blood goes toward the carbon dioxide. It when the heart rate is increases, okay, when heart rate is increases, so more blood goes toward the lungs and more carbon dioxide is lost again, okay. So this is simple mechanism. Now we will tell about the peripheral chemoreceptor work with the central chemoreceptor. For example, this is the peripheral chemoreceptor. These also work with the central chemoreceptor. Okay, they are communication with each other. So what will it do? It actually part of the central chemoreceptor is actually part of the central nervous system and cluster of neuron. You have to remember, central chemoreceptor is actually in the cerebrospinal fluid, okay, bathed in the cerebrospinal central chemoreceptor. Central chemoreceptor, for example, this is your brain, okay, this is your brain, these have a cerebrospinal fluid, okay. The central chemoreceptor are present, are bathed in this cerebrospinal fluid, okay. So you have to remember this, that are bathed in the cerebrospinal fluid, okay, and actually a cluster of neuron. So it actually partial partial change of partial pressure and pH, carbon dioxide and pH. For example, central chemoreceptor is monitor carbon dioxide concentration and pH. These are the these are the two things. And after that, it actually activates the respiratory center in the medulla oblongata. For example, partial pressure of carbon dioxide in the blood is this, okay. So what will happen? This carbon dioxide goes toward inside to the cerebrospinal fluid, and it combine with the H2O. When it combine with the H2, the HCO3 ion and hydrogen ion is formed. For example, H2CO3 is H2CO3. H2CO3 is formed. When H2CO3 is formed, it gives hydrogen ion plus HCO3 carbonate ion. Okay, so it gives hydrogen ion, and hydrogen ion actually decrease the pH. When the pH is decreased, the central chemoreceptor become trigger, okay, and it actually influence change in the blood flow or in the brain, actually increase the blood flow. For example, when hydrogen ion is increased, pH is decreased. When pH is decreased, the central chemoreceptor become activated. When it activates, it actually increase the blood flow toward brain. When the blood flow toward brain is increases, what will happen? Large mass, okay, when influence change in the blood flow toward brain. How? For example, this is respire, and another function is respire. It actually respire activate the respiratory center, increase the respiratory drive. Okay. Another is, for example, This is the vein. Okay, when the vein is squeezed, okay, after squeezing the brain goes toward the ischemia. Okay, metabolic carbon dioxide is increased, pH is decreased in cerebrospinal fluid, so detected by the central chemoreceptor. And actually it actually arteriole and vein constriction actually done with arteriolar vein constriction, more blood flow to the brain, and actually total peripheral resistance is increased, blood pressure is also increased. When the blood pressure is increased due to this mechanism, okay, the abnormality in the brain, okay, this is called Cushing reaction. When the blood pressure is increased in response to increased intracranial pressure, okay, what will at that process is called Cushing reaction, having Cushing. So now you have to we will simplify this mechanism now. How? So the first thing is, for example, when hydrogen ion is increased, actually central chemoreceptor activated, and central chemoreceptor when central chemoreceptor is activated, okay, actually it increase blood flow to the brain. One function, when blood flow to the brain is increased, there is the cerebrospinal fluid is increased, or the pressure, more blood goes toward the brain and the pressure is increased. The pressure is increased, okay, in the brain. One thing is that you have to remember this. Another, and more blood flow, so the hydrogen ion become normal here. Another is it actually central chemoreceptor respiratory center activate the respiratory center. When respiratory center is activated, okay, it actually increase the respiratory rate. So this mechanism. Now what will happen? Respiratory rate is decreased. Another thing is, for example, this is your vein, this is the vein, artery. If this become constricted, what will happen? Brain goes toward ischemia. Brain ischemia happen. Less blood goes toward the brain tissues, okay. When less blood goes toward brain tissue, again the central chemoreceptor is activated, and it increase the when brain go toward ischemia, again the carbon dioxide level is increased, hydrogen ion is increases, so pH become decreases. When pH become decreases, now what will happen? This is detected by the central chemoreceptor. When central chemoreceptor detect this change, what will happen? More blood flow to the brain. When this happen, okay, so after that more blood goes to brain. That is so much increases. This is so much increases. When this increases, now you have to remember that when more blood flow to the brain, total peripheral resistance also increase. More blood go to the brain. It's how it will happen. It becomes happen when total peripheral resistance is increases. When total peripheral resistance is increases, so more blood goes to the brain. Okay, and blood pressure is also increases, so more blood go to the brain. And if this happen, blood pressure is increased due to intercranial pressure. When the intercranial, now you have to remember, brain ischemia happens, so there is the intercranial pressure is also increases, okay. When the blood pressure is increased due to intercranial pressure, this is called Cushing reaction, okay. So this is so simple things. Now after that we will tell about the renin angiotensin system.